Hello everyone and welcome back to another video. So in today's video we're going to be going over the least common multiple and the greatest common divisor, the LCM and the GCD. And this is really how you're going to see it written out a lot as well. And let's go ahead and talk about what exactly they are. And perhaps this is best done by giving an example. So let's say we have 12 and 20. The least common multiple is going to be the smallest number that these both can divide. So for instance, this one I believe is 60. So we know that 12 goes into 60 5 times. And we know that 20 goes into 60 4 times. And there's actually a way to where you can figure out what it is without having to multiply these. And that's kind of the first way that you're taught, is that, well, one easy way of finding a multiple is just to multiply them, which is true, but that won't give you the least common. And so what we can do to figure out what the least common multiple is we can break these down into the prime factorizations. And so 12 breaks down into 2 and 6, which breaks down into 2 and 3. So 12 is equal to 2 times 2 times 3. And then 20 is equal to, let's do it right here, 10 and 2, which is equal to 5 and 2. So 20 is 2 times 2 times 5. And so the greatest common multiple is going to be the maximum of each of these. And what do I mean by that? Well, each of these have a number. This one has 2 2's and a 3. So let's say we have 2 2's and 1 3. So our maximum here, because we have 2, is 2. They're both equal to each other. But let's say that if we had a number like 6, then we would have 2 times 3, and this one would still have 2, so that would be the maximum. And the minimum would be 1 because this one has 1 2. And so we have 2 2's, a 3, and a 5. So if we multiply these together, we will get our least common multiple. And so 2 times 2 times 3 times 5. So this is 4 times 15, which is equal to 60. And so that's one of the ways to do the least common multiple. Break it into the prime factorizations, compare the two to each other, and take the maximum here. So let me go ahead and try to show you that in another way as well. Let's do 8 and 12. So 8 has a prime factorization here of 2 and 4, which is broken down into 2 and 2. So here we have 2 times 2 times 2. So 8 is equal to 2 times 2 times 2. 12 is equal to 6 times 2, which is equal to 3 times 2. So here we have 12 is equal to 2 times 2 times 3. Now we can write these in their exponential forms because 2 times 2 times 2 is the same as 2 to the third. And then 2 times 2 is equal to 2 to the second. And so when we're looking at our maximums, we're going to be looking at these exponents, and we're going to take the greatest of them. So here we have 2 to the third and 2 to the second. So our maximum is going to be 2 to the third because it's the bigger exponent. And then we go ahead and compare all of the numbers. So we would also compare 3. So here we have 3 to the 0 because any number to the 0 is equal to 1. And so here we have 3 to the 1 is the maximum, and 3 to the 0 is the minimum. And here, 2 to the second would be the minimum. And so this is 8 times 3, which is 24. And yes, 12 and 8 both go into 24. So that would be your least common multiple of 8 and 12. And a lot of times you'll see this kind of notation. So the LCM of 8, 12 is equal to 24. Now let's go ahead and talk about the greatest common divisor. So we're going to use a very similar technique here. And let's go ahead and actually do our same examples that we had. So 12 and 20. So we know that 12 was equal to 2 times 2 times 3. And we know 20 was equal to 2 times 2 times 5. Or 2 squared times 3 to the first. And then 2 squared times 5 to the first. And so here we're going to take the minimum, and that will give us our greatest common divisor. But what exactly is the greatest common divisor? Well, the greatest common divisor is the largest number that divides both of these. And so we can do this to find it. Obviously, we know with smaller numbers it's going to be a little bit easier, because we know this one can be divided by 4, this one can be divided by 4, and that's the largest number that divides them both. But mathematically we can do it this way to prove that this is the GCD. So here we're looking for the minimum. So again, we have 3 to the 0 here, and we have 5 to the 0 here. And so our minimum would be 2 squared times 3 to the 0 times 5 to the 0, which is equal to 4. Now let's go ahead and try another example. So something like 42 and 36. So we start by doing our prime factorizations again. So we have 42 breaks down into 2 and 21, which breaks down into 3 and 7. And so 42 would be equal to 2 times 3 times 7. And 36 is 6 times 6, which breaks into 2 times 3 and 2 times 3. So 2 squared times 3 squared. And so to do our greatest common divisor, we're going to look at each of the exponents now between the two. So the GCD, let's go this way. So the GCD of 36 and 42 would be equal to the minimum of each of these. Here we have 1, 1, 1. So the minimum here would be 2, because 1 is smaller than 2, times the minimum of this and this, which is 1. Oh, sorry. Yeah. So the minimum for the 2's would be just 1, 2. And the minimum for the 3's would be just 1, 3. And then the minimum for the 7's would be no 7's. So this is equal to 2 times 3, which is equal to 6. So our greatest common divisor here is 6. And we know also, like if we look at this, 42 and 36 are 6 away from each other. So 6 could be the biggest common divisor, because if it was 7, then 37 would be divided by 7, or let's say for an example here, but you would jump and it'd go to 43 instead of 42. So we know that 6 has to be the greatest that it could be, and then we do this to find out what exactly it is. In this case it was 6. And so our greatest common divisors and our least common multiples become really helpful whenever we are doing fractions, especially adding, subtracting, multiplying, all that fun stuff. And if you know how to do this kind of stuff right here, it makes simplifying fractions a lot easier as well. And we'll do videos on that in the future. But I hope you guys enjoyed the video, and stay tuned for another video with fractions. Have a good day. Bye.